All right, so today we're going to look at solving linear systems. Now this is a 3 equations system, okay, and also 3 variables. And you want to take extra caution when you're writing these down. Make sure that you're writing it correctly and make sure you don't make any mistakes. Otherwise, there'll be a long, very long road back to finding what was wrong. Okay, so just like the elimination for 2 variable systems, you want to do the same thing. You want to multiply and add 2 of them. So we choose 2 at a time. Okay, so look for a variable that has a coefficient of 1. Okay, because that's the best one. That's the easiest one to work with. So I noticed that for equation 1, I have a coefficient of 1 for the x and a coefficient of 1 for the z. All right, so which one do I want to use? It doesn't matter. I'll use let's go with the x, okay? So which other one can we cancel out with? Let's try equation 1, and equation 2. Okay. So what I like to do is I like to just bring these 2. Okay. I have x minus 2y plus z equals negative 11, and negative x plus 2y plus 4z equals negative 9. All right, so since these are opposites, we want to make sure that they're opposites first and then subtract. Okay, so sometimes we'll have to multiply. You'll see that later. But here, they're opposites already. 1x, negative 1x, opposite coefficients. So let's add straight down. Okay, so these cancel out, and we get negative 2y plus 2y is, ooh, this is nice. These cancel out as well. And z plus 4z is going to give us 5z. Oh, this one is too easy. Maybe I should have chosen a different one. Equals equals negative 20. Okay, so now we could solve for z here. We get that, divide by 5 on both sides, we get z equals negative 4. All right, and let's do the same thing with this one though. Okay, so I'm gonna write it a little different, okay, but let's keep the fact that z equals negative 4 here. And we're gonna multiply. We're gonna use equation 1, and we're gonna multiply it by negative 3. Okay, the reason why is because I want to get rid of this x, and the opposite of a 3 is a negative 3, so we're going to multiply it by negative 3. Okay, so we get negative 3x, and then negative 3 times negative 2y is positive 6y, and then negative 3 times z is negative 3z, and then negative 3 times negative 11 is positive 33. Right, and here we have equation 2. All right, so I'm going to put equations like the 1. Hold on. 1. There. I'll put the equations in circles. All right, so now I'm just going to write down equation 2 plus 2y minus c equals 7. So we have opposite coefficients, negative 3x and positive 3x. So we add those. They cancel out. Here we get 8y minus 4z equals, and then here we get 40. All right, and usually we would have two two equations with two variables, but here it ended up being pretty simple. Maybe I should have chosen a different one. Okay, so since we have z already, we can plug that in. And we get 8y minus 4 times negative 4, so z, equals 40. And 8y plus 16 equals 40. Solve for y. I'm going to subtract 16 on both sides. We get 8y equals 40 minus 16 is going to give us 24. And then divide by 8, we get y equals 3. So when you get two variables, it's going to be pretty easy to get the other one. You just plug them in, choose an equation, plug them in, and then solve. Okay, so here we get, now let's plug it into equation 1. Again, you can choose any of the three equations. Alright, so let's plug that in. We get x minus 2y plus z equals negative 11. So x minus 2 times 3 plus negative 4 equals negative 11. Oh, sorry. Okay. And now we get x minus 6 minus 4 equals negative 11. And x minus 10 equals negative 11. Add 10 to both sides. We get x equals negative 1. So add 10 to both sides. Negative 11 plus 10 is negative 1. And that's it. So our answer is going to be negative 1. It's our x, comma, our y, which is 3, comma, our z, which is negative 4. I might put another video up with an easy, more generic problem. This one is a little bit too easy. Okay, and there we go. Let's look at another type of problem. This one is x plus y minus z equals negative 1, and 4x plus 4y minus 4z equals negative 2, 3x plus 2y plus z equals 0. So find a coefficient of 1. Here we have 1, but here we have negative 1, and here we have 1 as well. So I would use 1 and 3 again. Okay, so let's change this to 2, and then this is equation 1, this is equation 2, this is equation 3. Okay, so I'm going to use equation 1 and equation 3 again, and we get x plus y minus z equals negative 1, and 3x plus 2y plus z equals 0. So we have opposite coefficients. Okay, so negative 1 and positive 1. So we're going to add. So 1x plus 3x is 4x. 1y plus 2y is 3y. Sorry. And then the negative z plus z, they cancel out, which is what we wanted. And negative 1 plus 0 is just negative 1. All right, a regular looking one. All right, now let's try this one. Let's try 1, and since we did 1 and 3 already, let's do 1 and 2. Okay, now we could do 3 and 2, right? We can multiply this one by 4, but here we would get pretty big numbers. We'd get, not big, but 12x, and then we would get 8y, and then 12 plus 4 is going to give us 16. 8 plus 4 is going to give us 12. So let's just stick with 1 and 2, okay? And you'll see something pretty cool. Actually, I'm going to put this over here. Okay, so I'm going to do equation 1 times, you want to get an opposite of negative 4. Opposite of negative 4 is positive 4. So to make that negative into a positive, I need to multiply by a negative and 1 times 4. So multiply this to get the opposite of this. Okay. And you always want to get rid of the same variable. Here I got rid of the z. Here I need to get rid of the z as well. Okay. Always get rid of the same variable. I don't know if I mentioned that before. And equation 2, we're going to leave that alone, right? Not multiplying by anything. And negative 4 times x is negative 4x. And negative 4 times y is negative 4y. Make sure I write dark so that I don't miss out any negatives. Negative 4 times negative z is positive 4z. And then negative 4 times negative 1 is positive 4. And just 2 is 4x plus 4y minus 4z equals negative 2. And look at this. We have opposite coefficients, but when we add, watch what happens. These cancel out. Oh no. And these cancel out. Oh no. So we end up with 0 equals 4 minus 2 is 2. Now remember in Algebra 1 where when you end up with a number not equaling some other number, and they're not equal. So if they're not equal, this is no solution. Ooh, I like these. Easy, right? Makes it shorter. All right. Now there's another type, which is like this. Okay, so it's going to be 3. Okay, this is equation 1. This is equation 2. This is equation 3. All right, so same thing. Find a variable that has a coefficient of 1, and there's a lot here. Let's use 1 or 2. 1 and 2. Okay. And we don't have to multiply anything because we have opposites already. X plus y plus z equals 8. And x minus y plus z equals 8. Opposite coefficients. So add x plus x is 2x. And these cancel out. 1z plus 2z, sorry, 1z plus 1z is 2z. 8 plus 8 is 16. Whew, almost made a mistake there. All right, so that's that. And I'm going to do the other one here. Now I used 1 and 2, so now I need to use either 1 and 3 or 2 and 3. Okay, so looking at this, I already have a negative y here, and this is positive y. So I'm going to use 2 and 3. And because they're already opposites, I don't need to multiply. So we have x minus y plus z, and I'm writing here. There we go. Equals 8, and 2x plus y plus 2z equals 16, and that's it. So they're opposites. So let's add 1x plus 2x is 3x. These canceled out. 1z plus 2z is 3z. Oh no. And then 8 plus 16 is going to give us 24. And you might have noticed something. So remember, you have to get rid of the same variable. Here we got rid of the y's. Here, that's why we had to get rid of the y's here as well. Okay, so now we have a 2x plus 2z and a 3x plus 3z. All right, so now these are the two equations that we want to work with. Ta-da! So this is our new number 1. Okay, so we have 2x plus 2z equals 16. And here we have 3x plus 3z equals 24. All right, so this is just like in Algebra 1, your two variable systems. And now we want to get opposite coefficients just like before. This one's going to be a little bit more tricky because we have 2 and 3. So one way to do it, it's not always going to be the best way, is to multiply by the other, choose the smallest coefficients. But here we have 2 and 3, 2 and 3, they're the same. So you want to multiply by the other coefficients. So here, our coefficient for x is 2. Here, our coefficient for x is 3. So I'm going to multiply this first one by 2. So multiply by the other coefficient. So multiply by 3. And here, I'm going to multiply this one by the other coefficient, which is 2. All right. But notice that the signs are the same. So we need to make sure that one of them is negative. It doesn't matter. Let's make this one negative. Why not? So we get negative 3 times 2x is negative 6x. Whew, almost made a mistake. Negative 3 times 2z is negative 6z. And negative 3 times 16 is a big number. Just kidding, negative 48. And then 2 times 3x is 6x. 2 times 3z is positive 6z. And 2 times 24 is, 48. Well, look at that. We have, we have opposite coefficients. So let's add straight down. Ta-da, these cancel out. However, these also cancel out, so we get 0 equals 0. Now, before where we had the numbers not being the same, it's no solution. Here, the numbers are the same. So this is many solutions, infinitely many solutions. Okay, just like before, it's going to be many possible solutions. But we can't really just say that, because we want to see what we want to find, like an equation expression for either the x, the y, or the z. So what we're going to do, all right, is we're going to take our equation, we're going to take either of these. Okay, I'm going to take this one. Why? Just because. Many solutions. So pick one of the newer equations. You can choose this one. I choose you. Pikachu. Okay, so I'm going to choose that one. So we have 2x plus 2z equals 16. All right, and now we want to solve for either the x or the z. Does it matter which one you solve for? No, it doesn't. So I'll solve for the x, just because. So I'm going to get 2x, and then we're going to subtract 2z from both sides. So we get equals 16 minus 2z, and then I'm going to divide by 2. So x equals 16 divided by 2 is 8 minus negative 2z divided by 2 is negative 1z. Ta-da! There we go. Okay, so here's our x. We got one variable. Now what are we going to do with that? We're going to plug it into the others. Okay, so let's plug this in. We can plug this into the either one. Okay, I'm going to plug it into this one. Right, equation 1. So plug it in. Plug in to original equation. Doesn't matter which one. To unoriginal equation. Let's plug it into 1. 1 is x plus y plus z equals 8. We're going to substitute 8 minus z into the x, because that says x equals. So 8 minus z, and then plus y plus z equals 8. Alright, and what do we get? Notice the negative z and the z, they cancel each other out, and we get 8 plus y equals 8. And then we subtract 8 from both sides. We subtract 8 from both sides, we get y equals 0. And it's usually going to be like that, where you end up with a 0. Alright, so there's our y. Now, you're wondering, what's our z going to be? Well, our z is going to be z. That's it. Okay, so the last variable that you have whenever you have the many solutions is going to be itself. So our answer is, our x is 8 minus z, comma, our y is 0, and our z is z. And that is it. Okay.